teaching platform. Still looking at application of differentiation in relation to small changes. Small changes. All right. So we have our fifth question over here. So we are to find the increment in y. We are to find the small increment in y, which is here this particular one. So we have to find the increment in y. All right. This one. In the function f of x is equal to 2x squared minus 3. Hence, estimate the small change in y changes when x changes from 2.1 to 2.2, right? So it means when x increases from 2.1 to 2.2, all right? We have to find the corresponding increment in y, the function given, all right? So let us start with. So our solution, all right. So we need to bring our function, which is f of x, will be equal to 2x squared minus 3. So we can let, because we have to find a small change in y, we can let our y to be equal to function f, all right? So in place of f of x, we are going to put y there. So y is now equal to 2x squared minus 3, all right? Good. Now, let us assume that the initial value of x is just x, okay? So x0 is x. When you plug in x, you are going to get the same function, all right? If you increase x by a small amount, okay, and you have another one to be, let's say you have the new x value to be x plus a small increment in x, all right? This is what you are going to do. You need to substitute the whole of this into the function, okay? So when you substitute the whole of this into the function, you are going to get a new result, okay? So this is what we are supposed to do. So it means when you substitute the whole of this, that is, when you substitute the first value of x, you get back to y is equal to the same 2x squared minus 3, all right? Then when you plug in our increment added to the x, you are going to get a new value of what? Y, okay? So here we are going to get, you need to multiply, in place of x, you are now going to substitute the x and its increment. So that will be x plus what change in what? X, in place of the x squared, then minus 3, all right? Now, when it comes to the left-hand side, you could say that the y, you are not going to get the same y value. The moment you have increased the x value, the y value to increase by a small amount. So here the y will be y plus, the new y value will be y plus 8 small increment, all right? So this is the idea that you are going to use to answer this question, okay? Good. So we have the function, let me bring back the function. We have the function to be 2x squared minus 3, all right? Now, if there is a small change in y, if there's a small change in y, then it means there has been a small change in what? X. Before there will be a small increment, okay? A small increment in y, it means there is a small increment in what? X. So let us assume that let let delta x be the small increment in x, all right? So our function will be now the moment you have, now you are going to substitute the increment to get y plus its increment, all right? increment that will occur on the y. So it means when you take your new function, you are going to substitute x and its increment. Okay, so it's going to be 2 multiplying x plus its increment, which is delta x in place of the x. So we have 2x squared. So in place of x, we are going to substitute x plus its increment because the x has been increased. The x has been increased. That is why we have a small increment on the y. All right. Then minus 3. Now, when you come to the left hand side, y2 will increase. Okay, y2 will be increased by a small amount. So that is the small change. So y will now be y plus the initial value of y is just y, all right? But the moment the x has been increased, it means the y2 will be increased by a small amount. So that is what I have here. That is what we are supposed to find. So you are going to get y plus small increments in y equal to, work on this bracket, you have x plus small increment in x, then multiplying x plus small increment in x minus 3. I've just expanded the bracket. So I'm going to get y plus small increment in y. Then let us expand the bracket first. So x times x will give us x squared. X times small increment in x will give us x multiplying small increment in what? X. Please don't multiply the x by the x attached to the delta symbol though. They are not the same. The delta x means small increment in x. And the x is the initial value of x, please. So you cannot get it as delta x squared. We write it as delta x squared is wrong. So now we take the delta x here to multiply this x. We are going to get x multiplying delta x, all right? Then delta x times delta x will give us delta x squared minus 3, our constant term. So let's continue. We are going to get it as y plus a small change in y equal to, let me close this bracket. The 2 here is multiply everything here. Let me write it here, sorry. It's rather here before the 3. Okay. So I have 2 here. I have x squared. Then I have x delta x. Then another x delta x. So I'm going to get 2x delta what? X. Alright. Then I'll be having plus delta x squared in bracket minus 3. So here we are going to get it as y minus small change in y. Sorry, it should be plus. It's not minus. Y plus, sorry, the brain is tired. So y plus small change in y equal to, now we expand this bracket, we're going to get 2x squared plus 4x multiplying delta x, all right, then plus 2 also multiplying delta x squared minus 3, all right. We are to look for the value of delta y, that is a small change in y, so we make delta y the subject. So we are going to get delta y to be equal to 2x squared plus 4x delta x plus 2 delta x squared minus 3, all right, then minus y, all right. So we are making delta y the subject. So, but we know our y to be the original function, which is 2x squared minus 3, all right. So we are going to plug in the value of y. So this will give us our delta y to be equal to 2x squared plus 4x delta x plus 2 multiplying delta x squared, okay, minus 3, then minus the function y. So for y is 2x squared minus 3. All right. So we have 2x squared here. We cancel this 2x squared because when you expand the bracket, you are going to get negative 2x squared. So it's going to be 2x squared minus 2x squared, which will give us 0. Then yet we have negative 3 minus negative 3. So it's going to be negative 3 plus 3. So this and this will also cancel out. So now delta y, our delta y will be equal to 4x multiplying small change in x plus 2 times small change in x squared. All right. So this becomes the function in terms of delta x. So this is the first part of the question. This is what we have to find. We have to find the small increment that has occurred in y. So this is the small increment that has occurred in y. Now we have to estimate the small increment, the value of the small increment when x changes from, that is 2.1 to 2.2. All right. So it means x has been increased from 2.1 to 2.2. So we need to find the small change. So small change in x is equal to the final result, which is 2.2 minus the initial x value. All right. And that will give us 2.1. So at the end, you are going to get a small change in x with 0.01. No, it will be 0.0. There shouldn't be 0.1. Yes, just 0.1. All right. So this becomes a small change in x. So you just need to substitute this value into your function in terms of delta y, sorry, in terms of delta y. So we have our delta y to be equal to 4x. What's the value of x? The x is the initial x value. So that is 4x is the value of x is 2.1, the first x value, multiplying the small change, which is 0.1, then plus 2, also multiplying the small change, which is 0.1 with a square. Okay. So our small change in y will be equal to, so let us work on the first side. We have 4 times 2.1, all right, times 0 times 0.1. Okay. That part we are getting it as 0. Write it well, 0.84. Then plus work on the other side. So we have 2 multiplying 0.1 in bracket squared. Okay. That part is also 0.02. So at the end, we are going to add the 0.02 to the 0.84. So plus 0.84. And this will give us a result of 0.86. So this is the small increment that has occurred in y as a result of 0.1 increment in the x value. All right. So this is what you are supposed to work on. Thank you for watching. Please do not forget to subscribe to my YouTube channel, which is Math with MFR.